I do not hear your voice, madam. I think,
Yes, you can start.
madam, can you hear my voice?
Yes, sir. Yes, sir. Yes, sir. We are on live, sir, now.
Evening
Yasmin, you
is
can
the
start.
evening is the time for peace, where there is no tension to cease. Good evening. I absolutely delighted to welcome you all for the 3 days national level workshop on recent trends in fuzzy inventory models, zero supermodel and differential calculus and its application, organized by Internal Quality Assurance Cell (IQAC) and Department of Mathematics, Krishnaswamy College for Women. Mathematics is the most beautiful and most powerful creation of the human spirit. Once again, I welcome you all for the second day program session on some features of Zero Supermodular Lattice by Dr. J. Arivukkarasu, sir, Associate Professor and Head Department of Mathematics, Vivekanandha College of Technology for Women, Tirruchencode, Namakkal. The main aim of the workshop is to create an in-depth knowledge and exposure about various topics in mathematics, which helps to enhance the learning and the understanding skills on mathematics. I hope you all will be benefited by participating in the 3 days of workshop. I am S. Yasmin, Assistant Secretary, Department of Mathematics. I have the privilege to being the host of this program. Now, I would like to welcome Dr. R. Esther Felicia ma'am to deliver the welcome address.
Good evening to one and all present here. It gives me an immense pleasure to extend a warm welcome to the Chairman and Management Trustees, Krishnaswamy Educational Trust, our Dean Dr. R. Revati ma'am, Principal Dr. Anita Rajendran ma'am, and the Internal Quality Assurance Cell. I extend a pleasant welcome to our eminent guest of honor, Dr. J. Arivukkarasu sir, Associate Professor and Head, Department of Mathematics, Vivekananda College of Technology for Women, Tirruchencode, Namakkal. Welcome, sir. We are happy to have you as a resource person for today's session on some features of zero supermodular lattice. I welcome all the participants from various institutions who seek to enlighten themselves from this valuable session. Thank you, sir. Thank you.
Thank you, ma'am. Now, I would like to invite Ms. J. Sobia ma'am to give a brief introduction of our chief guest.
Thank you, Yasmin. Good evening to one and all present here for the 3 days national level workshop on recent trends in fuzzy inventory models, zero supermodular lattice, and differential calculus and its applications. Myself, Ms. Sobia Venkatraj, Assistant Professor, Department of Mathematics, Shri Krishnaswamy College for Women, profusely overjoyed to take the opportunity to introduce our chief guest of the day, Dr. J. Arivukkarasu, Associate Professor, Head Department of Science and Humanities, Vivekananda College of Technology for Women, Tirruchencode, Namakkal. Sir has completed his MSc, MPhil, and PhD in mathematics, MS in education management, MSc in psychology, MA in English language and literature, MSW, MA in yoga for human excellence, PGDCA, PGDHR and HV, BGL, BLIS, and BL. Sir has more than 20 years of professional experience as a teacher, lecturer, assistant professor, and head of the department. SAR has published 6 papers, and out of these 6 papers, 4 papers are published in international journals and 10 papers are sent for publication. It's a great thing that SAR has introduced zero supermodel lattice in his research. SAR has invited for lectures in more than 15 colleges all over Tamil Nadu and one college from Guntur, Andhra Pradesh. SAR has presented more than 20 papers in national and international conferences. He has also participated in more than 50 programs such as workshop, seminar, faculty development program, national and international conference. Sir has more than 20 years of professional experience. He has worked as a teacher in St. Peter's High Secondary School, Tanju. He has worked as a lecturer in Adikalamada College, Tanju, Adi Parashakti Engineering College, Melmarote. He has worked as an assistant professor in many colleges such as Christ University, Tanju, Sudarshan Engineering College, Pudukkottai, PSN Engineering College, Tirunelveli, JPR Institute of Technology, Chennai, Gojan School of Business and Technology, Chennai, Shri Muthukumaran Institute of Technology, Chennai. Staff has worked as the head of the department in PGP College of Engineering and Technology, Namakkal. At present, he is working as a head Department of Science and Humanities in Vivekanandha College of Technology for Women, Namakkal. Sir is also acting as a question paper setter in Vignan's deemed to be University, Guntur, Andhra Pradesh, PSN College of Engineering Technology, Tirunelveli, Prest University, Tanjore. He is also a journal reviewer in International Journal of Industrial Mathematics, Elixir Journal of Applied Mathematics, Global Journal of Pure and Applied Mathematics. He is also a subject expert in ChatIndia.com Advanced Math. Sir is also a guest faculty in Banskas College for Women, Tanjore, Meenakshi Chandrasekharan College for Women, Pattukotai, Arasu College of Arts and Science for Women, Karur. Sir is also acting as a mentor in the Masterminds International Institute, Africa. I feel it is a great honor for me to introduce you, sir. Thank you.
Thank you, ma'am. It's an quite exciting session we have ahead. I truly hope that the session will be informative and useful for all of us. Now, I would like to invite Dr. J. Arivukkarasu sir to take over the session.
Dear participants, kindly wait for few moments because of the technical
Hello.
issues.
சுத்தமா வாய்ஸ் கிளியரா கிடைக்கல சுத்தமா
உங்களுக்கு கிடைக்கல சார்
சுத்தமா எனக்கு சுத்தமா கிடைக்கல
அப்படிங்களா சரிங்க சார் இப்போ நான் உங்களுக்கு இன்ஃபார்ம்
Wait for a few minutes. We'll back in session. I hope this is a technical issue.
Yes. Ma'am, can you hear my voice?
Yes, sir. Yes, sir. Your voice and your video is fine, sir. You can start now, sir.
Okay, okay. Thank you very much, madam. Thank you very much for your introduction and welcome to the program. And before that, I wish to thank the management people as chairman, directors, dean, and principal, and a special thanks to Dr. R. Esther Felicia ma'am and team members for inviting me for the 3 days national level workshop on the title of 3 different topics. It's a really good time to me to expose my idea and other things about the research. And before I have to start my talk, I want to give some things what the existence, what is the reason. Because the title of the content the recent trends in the particular topic. This is the first one, isn't it? But the recent trends means inventory. I think yesterday our Bresh, as a presenting the paper, presented the topic inventory, fuzzy inventory model. But in myself, I have to introduce zero supermodular lattice. I do not know whether the people know about the topic zero supermodular lattice. The thing is very important. The third one is differential applications of differential calculus. But I proud to say that it's a very simple thing. Recent trends in zero supermodular lattice, but the zero supermodular lattice is the recent one, because at the time of introduction, ma'am introduced, I introduced the zero supermodular lattice, but from the beginning, that means the lower level students, the BSc students may in the line. Otherwise, the research scholars and faculty and many people are there in the line. I think so. But the thing is very important there. Most of people thinks that mathematics is the toughest subject. If many people are doing research, I think so, and ma'am is Esther ma'am is available. But if we are doctorate means, if you tell to Dr. Esther or Felicia and Dr. J. Arivukkarasu, Dr. Yasmin, whatever it is, if you tell your doctorate, the people may ask you which subject. If you are telling a mathematics means, the people are astonished. How to do research in mathematics? But it is very complicated. Many of people are thinking that it is very complicated, but the thing is very interesting one. In myself and people of doctorates may know how to do research in mathematics in easiest way, but it is the time to tell what is the research, how to do research in mathematics, how I did my research in easiest way. This is the thing I want to express you now, because it is the recent one. That's what I'm telling you now. Well, before I start my talk, I wish to tell one thing. Whatever whatever the research as a new trend, only from the existence, only from the existence. You need to know entire fundamental from the existence. From the existence only, we pick the new branch. Otherwise, you create the new branch. This is the first thing we must know about it. Okay, I'll give you a very beautiful example to that. You know the algebraic identities. What are the identities? A plus B whole square means A squared plus 2AB plus B squared. And A plus B whole cube means what is A cube plus 3A squared B plus 3AB squared plus B. You know the identities. But the thing is very important. How the formulas is invented. Otherwise, they created the idea behind it. That is important. What is I want? You know one thing, the Pascal's triangle. You know everybody know about the Pascal's triangle for mathematics people. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The Pascal's triangle. You know one thing, if you know the Pascal's triangle, otherwise, using the Pascal's triangles, we can make many formulas. We can make many formulas. You know one thing, in Taylor series, your engineering level or BSc or MSc level, if you need to know what is the Taylor series, you say the base of the Taylor series only from the Pascal's triangle. It's simple, because existence is important. From the existence, we can make many formulas. We can make many formulas. I think we have only another time. Within another time, I want to give a gist of the mathematical research about the zero supermodular lattice. Okay, it is a big one. It's a big one. I have prepared the PPT more than if I want to prepare present the paper about the zero supermodular lattice means it takes more than 3 hours or 4 hours, because I have prepared that like a PPT. But I want to give some beautiful things to you all. Well, you know one thing. When the time of my research, my advisor, my research advisor is my Maria Puso, Dr. A. Vedamanikam. He is a retired associate professor, Rani Anna Government College, Tirruchencode. He told one word anytime, Arivukkarasu. Mathematics contribute many things. Mathematics contribute many things, but what we contribute to mathematics, that word inspired me. That word inspired me. I did my research. But before I introduce the zero supermodular lattice, I have studied many lattices like generalized supermodular lattice and zero semi-modular lattice, Eulerian lattice. A lot of lattices I have derived, but that word inspired me. I have introduced zero supermodular lattice. You know one thing, in Ilayaraja song, there is a song, I think a beautiful song is there in Wolf film. If you invent anything means you are like a god. If you introduce anything means you are like a god. In Tamil song is available. But what I want to tell, it's a time to pride and proud to say about the zero supermodular lattice. Because if you go type in Google search zero supermodular lattice means, you just type the word and touch the enter, J. Arivukkarasu will appear. Dr. J. Arivukkarasu will appear because I introduced the concept of zero supermodular lattice. And you are all the mathematics people, but you know have a better knowledge than me. But I wish to share my own experience how I found the zero supermodular lattice. As a beautiful example, I want to explain you now. A small spark makes and a big fire. A small spark makes and a big fire. Likewise, a small idea makes a better research. Making definition is very easy. Making definition is very, very easy. But writing theory over the definition, it is not possible, I think so. This is what I want to tell you now. And apart from that, how I found the zero supermodular lattice. This is the thing I want to explain you. It's a very, very short term. It's a very simple thing. I want to give a brief history within a 2 minutes. In 1978, Iqbal Unisha, this is a women's college, so that I want to represent it. It is a very prime thing to represent about the two people. One is Dr. Iqbal Unisha. She is the first women doctorate in Muslim community in India. Iqbal Unisha, she is the first women doctorate in mathematics in especially Muslim community in India, first woman. The second one is everybody know her because Vasanta Kantaswamy, as a former IIT professor, he is the research scholar Vasanta Kantaswamy under the guidance of Iqbal Unisha. She introduced supermodular lattice. She introduced supermodular lattice. I will explain everything in my PPT. But before we, if I am presenting PPT means, what is that? We don't know. But once you know something, you can easily see the presentation. Then only you can understand something from me. That is what I am representing here. In 1978, the supermodular lattice introduced by Iqbal Unisha and Vasanta Kantaswamy. The thing first is over. In 1978, I'm telling that its paper is published in 1980. Isn't it? But very simple. The term is over. Now, I'll come to the another point. There are a lot of lattices available. There are a lot of lattices available. As a very thing, that is a protocol from this. From the element, we represent set. From the set, we represent two relationship. One is by the relation, we represent two sets. One is equivalent set and partial set. Okay, but the equivalent is a different category. But I want to represent partially ordered set that represents coset. From the coset, we can define lattice. Everything I'm given in the presentation, but just I want to give us some outline about it. Okay, from the lattice, there are lot of lattices available, and the prime most lattices, one is distributive and another one is modular. This is the two things is very important. Why I want to tell about the modular lattice and distributive lattice means, that means the supermodular lattice, the equational class of supermodular lattice between the equational class of modular and equational class of distributive. This is what Iqbal Unisha and as well as what is it? This is the first prime thing. 2014, I searched a book in Taramani. On the time, I took a book, Supermodular Lattice. I took a book, Supermodular Lattice, in that library because she is the first women director for Ramanujan Institute, Unisha. So that book, I kept the book and opened the book. I read different things in Supermodular Lattice. In 2014, my research advisor and me discussed many things at the time of research. The thing was, at that time, modular zero, zero modular is available. Zero distributive available. Semi-modular, zero modular available. So, the zero condition, everything available. Zero conditions available for all lattices. The simple idea, what I want to tell you, a small spark makes a big fire. That small idea makes a good research. That's what I'm telling you now. If it is a super model available, that is existence. That is existence. That what I want to do now, what the idea of a zero distributive zero modular, just I try to make a simple definition from the super modular by that name as zero super modular lattice. Just I told the word and what is it? Making definition is very easy. Yeah. Zero super. Well, Vasudha as well. And zero super model is a from model lattice. Just the definition I showed to my research advisor. My research advisor has told to Arivukkarasu, okay, no problem. You wrote the beautiful definition. Okay, is it right? Okay. But how is it possible to make another step to move through the zero supermodel lattice? That's what I'm going to present you now. Okay, 1 minute, please. I'll share my screen now.
No, sir, your screen is not visible.
Not visible. I think so, but I want to tell you something about it. Okay. At zero, so I just my advisor think that it is a supermodel lattice and equational class. Supermodel lattice and equational class.
Excuse me, sir.
One, please, ma'am.
Sir,
Is it visible?
yes, sir. If it is so, you can off your video, sir. So then we can get an uh, correct
Oh, okay, okay. I try
network.
to, try to.
Yes, sir. Yes, sir.
Okay. 1 minute, please.
Because of the video, you
Right.
can not able to share your screen, I think so.
Oh,
Yes, sir.
I think so. 1 minute, please. Madam, madam, is it visible now?
No, sir, your screen is not visible, sir.
Not visible.
Yes,
One
sir.
minute. One minute. Yeah. Yeah. Is it visible now?
No, sir, it is not.
Is it visible now?
No, sir, no,
Well,
sir.
it's visible, I think so. To me,
Kindly make your.
no, it's still not visible. Huh? Now?
Yes, sir. Now it is visible, sir. But we can't
Okay.
able to.
Well, is it better now? I think Shah has experienced. Ma'am, can you hear my voice?
Yes, sir. I'm hearing your voice, but it is also your voice is also
Screen is
having.
not visible. Some problem, I think. I think,
And
my
also,
screen is visible or not,
and
madam?
also your
Please.
screen is also not visible, sir.
I think it's still running my laptop. I think so.
Now it is visible, sir. Yeah, just now it came, sir.
Now visible. Okay.
Yeah, just now it came, but you turned off your screen share, I think so.
Okay. Okay. 1 minute, madam. Please. I will check it. 1 second. Okay. Okay. Yeah. 1 minute. I'll. It's possible. It's quite possible. Well, before that, before my screen share, I will discuss with you about the zero supermodular lattice. 1 minute, madam. It's running. It may open in a few seconds. It will take a few seconds only. Okay.
Yeah, sir, your screen is visible now, sir.
Screen visible now.
Yes.
Okay. Yeah, it's more. Okay. Yeah, I pick up, I think so. Within a few seconds, madam. But I want to tell you now about the zero supermodular lattice. When I start my research, and as well as the topic of zero supermodular lattice, and before that, my research advisor discussed many things about the Eulerian lattice. Because on the time of relativities, they discussed equational classes. Equational classes. Why we want to discuss with the equation? When I am starting my zero supermodel lattice, after that, after making the definition, I try to prove some results by basic statements. What is this? The direct product, and as well as can you hear my voice, ma'am?
Yes, sir. Yes, sir. Can
Oh,
hear
thank you very
you.
much, ma'am. Well, equational class. There are three things. If you the equational class as satisfying the three conditions. The first condition is a direct product. The second one is a sublattice. The third one is a homomorphic image. The three things. When the equation satisfying the three conditions, that is called simply equational class. Simply equational class. One minute. Equational class. I am trying to solve the problem by using the zero supermodular lattice. But my screen is visible, madam?
Sir, we are visible. We are using your thank you slide, sir. Yeah, now it's
Yeah.
okay.
Now, oh, thank you very much, madam. Okay, thank you very much for this. Well, it's a making a, I think I written the statement. First, is the zero supermodular lattice satisfying the product rule, direct product? The second one is zero supermodular is a sublattice? The third one is zero supermodular is a homomorphic image? If the three things are satisfied, what is it? One is the direct product, the second one is sublattice, the third one is homomorphic image. If the three things are satisfied means the given equation is simply called equational class. The thing is first important. But what I did in my research, I am trying to solve the problem in the easiest way. It is my first role to solve the beautiful problem as a direct product of zero supermodular lattice is zero supermodular lattice because every statement has only created by me. Okay, I'm trying because the definition is okay, but is it possible to solving the problems? That is the thing is I'm trying. As the first one, I try to solve the problem as the product of zero supermodular lattice is zero, so it's satisfied. I will show my screen. Okay, the second point is the sublattice of zero supermodular is a zero supermodular lattice. The third one is I am trying to solve the homomorphic image of zero supermodular lattice is zero supermodular. I'm trying, but on that time I realized it is not satisfying for homomorphic image. It is only satisfying for monomorphic image. Actual definition is very simple that if direct product, sublattice and as well as homomorphic image means the given equation is a simply equational class. It is the first thing. But I am trying to solve the problem for zero supermodular lattice, but it is a very simple. It is not homomorphic image. It is a monomorphic image. So it is not an equational class. It is not an equational class, but it almost equational. Instead of homomorphic image, my definition satisfying only the monomorphic image. This is the first initial stage. All the mathematics people should know whatever the content we have in my hand, we have in your hand, you try to solve in the existence methodology. If you know the existence methodology to solve the entire problem, you have to put it to the actual definition to this statement. You trying to solve the problem. Once you solve the problem means you can easily understand that the problem can solve in easiest way. Then apart from that, it is a very simple. It is not a monomorphic image. I am going to give as a beautiful thing to you all now. 1 minute. I think something went wrong in my screen sharing. 1 minute. I'll try to explain you everything in my easiest way to understand the concept. Okay, 1 minute, please. Yeah, it's 1 minute, please. Yeah, that's it. Once again, I share my screen. I think, ma'am. Yeah, I think it's visible.
Yes, sir. Now it's visible, sir.
Yeah, thank you. Sorry.
So, slides are also changing, sir.
Yeah, well, I told you already from the protocol is a very simple elements. Yeah, from the elements we define set. From the set is a major load. One is equivalent set and another one is partial set. I am going to define that the partial set in my screen. I think everybody, because I would not like to give a more definition about, because it's known thing to all the people, because it is a very basic thing. But I want to tell what is zero supermodular lattice. That's what I'm going to represent you now. Okay. Now it's you know very well why the Warsaw ordering relation less than or is equal to it satisfied reflexive, antisymmetric, transitive. Reflexive, antisymmetric, transitive. That is called a partially ordered set. If it is reflexive, symmetric, transitive means that is equivalent set, isn't it? Now, you know the comparable. Well, the lattice. I think it is very interesting fact we are going to discuss. Without knowing the lattice structure, lattice definition, you cannot explain anything in that way. A poset P less than or is equal to. And the protocol I told you, from the poset only we can define only lattice. From the poset, L less than or is equal to is a lattice if you have supremum and infimum exist for all pair of elements. Well, supremum is denoted by the down arrow. The down arrow in set language that represents union. In before the lattice theory, they are representing cup cap, but I am representing you that the down arrow represents join. The down represents as a joint supremum, that is the greatest lower bound. The greatest lower bound in real analysis you can easily see the greatest lower bound, and infimum defined by the upper arrow mark, that is called meet, that is called least one. Okay, and sublattice definition I have given you, that you know very well about the sublattice subset. The definition of subset is related to sublattice because the condition should be satisfied on the set. It is called a sublattice. That is a very simple. And that I told you that homomorphism, the homomorphism, the homomorphism in lattice theory. You know one thing, from the set theory only we are defining the lattice theory. I representing here, it's a very simple thing. What is it? F of A join B. Listen, the arrow mark I am representing join. There are two lattices. A homomorphic image, we take two lattices, L0 join meet and L1 join meet be the two lattices. Then the mapping F L0 to L is said to be homomorphism. The definition, I think all the people can easily understand the definition because it is a very basic thing. Even though as a school student can easily understand the concept, you know, by union and intersection. Likewise, I am representing here F of A join B is equal to F of A join F of B, and F of A meet B is equal to F of A meet F of B for all A comma B is belongs to L0. As a mathematics people, you should know about the homomorphism things. Well, I am representing here a monomorphism is an injective homomorphism. This is what, why I am representing here about the monomorphism. In my zero supermodular lattice, a homomorphism, it's not possible for it. If it is not possible, I explain a beautiful thing about the research and in mathematical research. But I am proving that monomorphism. Apart from that, why I am representing these topics? At the final set, I will represent you a semi-lattice, atom, dual difference, isomorphism, direct product. I told you that direct product. You know something, variety. This is what I'm going to represent you now. A class, well, sorry. 1 minute, sorry. Yes, homomorphism. Yeah, variety. This is what I want to represent you. Very important thing. A class K of lattices is a variety if and only if K is closed under the formation of homomorphic images, sublattices, and direct product. This is what the first try to solve in zero supermodular lattice. These three things only motivate me and lift me in the topic of zero supermodular lattice. That's a real thing. Because once we started the research, if you find anything new or if you solve any problem in beautiful way, it is the running line for the researchers. That's what the first thing is. And another one is equational class lattice, as I'm representing you already. Because the second line is very important. We note that HSP theorem, H homomorphism, S sublattice, P product. That is what they're representing HSP theorem, that the class K is a variety if and only if K is an equational class. That is very important. Variety and equational class is the same. Variety and equation class are the same. Apart from that, I am representing here complementary lattice, modular lattice. It is very important, modular and distributive, because these two things only as a prime thing to motivate the another step. Well, apart from Boolean, S of L, S of T, and another thing, zero distributive and zero modular. I'm told that from modular from distributive, as one of the familiar scientists, J.C. Warlet introduced the zero condition for zero distributive and zero modular. Listen, if a modular, okay, distributive, okay, and zero distributive and zero modular, is it possible? This is what I want to tell you now, because these things, this idea only motivates me to implement, otherwise to introduce the new concept about this. Okay, then, and pseudo, why I am representing these type of things, this type of lattices means that I introduce the definition. I correlate the zero supermodular lattice into many lattices. I'm trying. I tried to solve on many problems. I tried on many solved problems. This is the first thing I want to represent now. Because if you find, if you create one thing, you just implement to another part. With another part, it's quite possible to continue our researches. That's what I did here. And I told you that Iqbal Unisha and Vasanta Kantasamy have introduced the class of supermodular lattice. Their definition is given. It is a very big definition. It's a very big definition. There is an equational class, I think so. Isn't it? From this definition, that definition is very long. I think I am representing now. A join B, the first, meet. A join C, meet. A join D is equal to A join B meet C, meet A join D, C meet D, meet A join D, join B meet D, meet A join C. This is the actual definition. Please be listen one thing, how I introduced zero supermodular lattice from this definition. Please look at here, in right hand side, you look at it, the first bracket, the first two elements, what is it? B meet C. It's a really interesting fact. B meet C. Okay. The second bracket, the third bracket, the second bracket, that is a C meet D. And the third bracket, the first two elements, B meet D. Listen, B, C, D. This is the first thing. Well, I am selecting three distinct elements from the set. Once again, I am selecting three elements B, C, D from the set. If it is distinct elements means the meet element, meet means the least element, meet means the least element should be zero. Should be zero because distinct. Distinct means there is not related with it. Okay. So the relationship between the two elements under this what way? It touches in the lowest part of the diagram of the lattice one. Okay, so that B meet C equal to 0, C meet D equal to 0, B meet D is equal to 0 means we represent in right hand side only for A. That the definition I have represented here. Well, yeah, this is what I'm representing here. Definition, a zero supermodular lattice as follows. This definition as introduced by me and my Maria Puso, Dr. A. Vedamanikam. A lattice L with 0 is called a zero supermodular lattice. If whenever B, C, D in L satisfy, I told you already, B meet C, C meet D, D meet D. Three meet elements is equal to 0 because of the main reason the three elements are distinct elements. Okay, when you substitute the value, the big equation, the supermodular equation, A join all other things, okay, as comes to only 0. So A join 0 means that comes to obviously the biggest element A. Okay, meet means the least element, join means the biggest element, that means the highest element. Okay, now I am representing you, this is the first definition I am representing for the zero supermodular lattice. Okay, sir, you introduced the zero supermodular lattice. Okay, no problem. But how I am representing for the zero supermodular lattice? By the diagram, by the simple diagram, because solving the problem is a different category. Okay, but if you want to prove, we must use some diagrammatically. When you are topological spaces and topology part, whatever the problem, we can represent by the pictorial one. Okay, likewise, this is the main prime thing to represent you now, because this diagram is representing how I introduced zero supermodular lattice. First one is poset. From the poset, we define lattice. From the lattice, there are lot of lattices available, but the prime lattices is only two. One is modular lattice and another one is distributive lattice. Again, from the modular, J.C. Warren, one of the best scientists in lattice theory, I introduced in 1978 zero modular lattice. And distributive lattice, J.C. Warren introduced the zero condition for zero distributive lattice. But Iqbal Unisha and Vasanta Kandasamy madam both were introduced supermodular lattice between modular and distributive. I think you can easily understand how I understand the whole concept about the supermodular and zero. So that what I thought, that's a beautiful idea led it me. From the modular, is it possible zero modular? From the distributive, is zero distributive is available? Why it is not possible for zero condition supermodular? So only I am representing in green color zero supermodular lattice. So this is the beautiful idea. I think I in my mind, I received some idea about this zero conditions. So only I wrote the definition, and as the important thing, after the definition, it is the prime thing. You know one thing, I am representing here C4 as a diagram. Sir, how is it C4 diagram means? Listen, it's a very simple to represent the name. And in the first, second row, there are 4 points. And upper part there's a 4 points. So I am representing, it is a, you know one thing, in there are many things is available, but I am representing down here. It's representing a C4 diagram. I quote some points. What is it? A, B, C, D. I quote some points. A, B, C, D. Listen one thing. From these points, from these 3 points, I am representing one thing here. What is it? Yeah. I represent A, B, C, D points. You take a point and substitute into, what is it? Supermodular lattice. If it is applying a supermodular lattice, this is what I showed here. It is not equal. I think the left hand side is not equal to right hand side, means it is not a supermodular, but this diagram only as insist me to move the next level, because I consider that zero supermodular lattice, it is not characterized. How we can characterize this zero supermodular lattice? By the diagram. This is what I represented here. That the point is representing now. So only I take C4, because this diagram C4 is zero supermodular lattice, but not supermodular. C4 is zero supermodular lattice, but not supermodular lattice. But the converse is true, because the supermodular lattice is always zero supermodular lattice. You know one thing, when you are read the real analysis, algebra, you know one thing, the converse is a very important part. Once, if you do not go the same line, you just see the back one, because the converse is very important. The converse is very important. So that I first is a prime thing. I select the C4. I checked the elements, all the elements. I checked all the elements to substitute in this equation. I am representing and concluded that it is the first thing, because in algebra, there's a very important thing is, if you prove one theorem, means that should be universal truth. That should be universal. If anyone come and disprove that, means it is not an actual definition or actual statement. I'm trying to prove the actual statement about the topic. So only I'm taking here C4 as a zero supermodular lattice, but not supermodular. This is the thing. And then this is what an actual definition I'm representing here, zero supermodular lattice. Okay. Now, I told you already, I checked The product of supermodular algebras is supermodular. Why? I'm told that lattice, but I'm representing here algebra because I'm using the binary operations. I'm using the binary operations. So only I'm representing here that supermodular algebra. But when I'm starting my research, I proved that zero supermodular lattice. But the foreign evaluator, one of the familiar scientists still now, Androja from Serbia, ma'am as suggesting me that at the time of queries, the correction of my thesis is simply, ma'am said that as a very simple, why you are representing that only the first chapter only, we are representing only the binary operations. Once you use the binary operations, it makes an algebra. So that you represent the first theorems or everything as a based on algebra. So that I'm trying to much, I not trying, I changed everything, a product of zero supermodular algebra is a zero supermodular. The proof is given here. Okay, it's not a right time because within I have only 10 minutes time. I want to give a beautiful thing to you. That's what I'm representing. I told you that homomorphism, sublattice, and as well as direct product. If you satisfying the three condition, the given equational class is called, what is it? Equational class. Okay. Now, equational is equational class. Now, I am representing, apart from that, the theorem is representing the sub-algebra of a supermodular algebra is zero supermodular, and the thing is important. In the following theorem, we have taken theta as an onto homomorphism because we need to that homomorphic image of under theta. But what I have proved monomorphic image of a zero supermodular algebra is zero supermodular. But what I want to prove homomorphism. But what I have proved monomorphism. Okay, so it is not an equational class. It is almost equational. It is not an equational class. It almost equational. This is what the first representation, and through these three things, I representing a unique statement. The theorem I am representing here, the class of pseudo supermodular algebras is closed under the operations taking subalgebra, direct product, and monomorphic images. These statements given by Arivukkarasu and Dr. A. Vedamanikam. What I think you can understand that because I told you existence. Direct product is existence. Sublattice, subset is existence. Homomorphic image is existence. But I am taking a new way, that is a zero supermodular. I am trying to prove zero supermodular lattices is satisfying the three conditions. This is what the research has come out. First thing. Well, the statement is proved. Apart from that, well, it is a real fact. I want to tell a beautiful truth about mathematics. What is it? Once you take a statement, you try to prove the theorem. You write the statement, you try to prove the theorem. If it is proved means it's really excellent. If it is proved means it's really excellent. Once again, if it is not possible to prove that statement means you must give the counter example. You must give the counter example. Why it is not? Counter example. If it is not possible to give the counter example means you just make the definition as a conjecture. I realized that thing in my research because in my thesis, in my research work, I have given 6 open problems because I couldn't able to prove, I couldn't able to disprove. Isn't it? I make it as conjecture. I realized once again, you make a statement, you try to solve the problem. If it is solved, okay, good. If it is not possible, you just try to give a counter example. Okay. If it is not possible to counter example means the statement as a conjecture. May the future scientist may try to solve the problem. Isn't it? Now, in my screen, what I am representing, this is what, because Androja, as one of the familiar scientists suggesting me, a very simple thing, Arivukkarasu, you try to prove the problem for the monomorphic image. If it is not homomorphic image means, what is the reason? You must give the counter example for the homomorphic image. That's what I'm given here, the counter example, because a zero supermodular lattice. In my screen, I am representing a zero supermodular lattice whose homomorphic image need not be zero supermodular, because I am trying here that monomorphic image of zero supermodular algebra is supermodular. But if it is not homomorphic image, means we must give the counter example. Listen one thing, this a counter example I have given here for the not a homomorphic image, because this diagram is zero supermodular lattice. This diagram is a zero supermodular lattice. If the homomorphic image is only the top one, the homomorphic image I am representing the top one. Top one means what is it? M4. That is a 4 element. The M4 is not zero supermodular lattice. M4 is not zero supermodular lattice, because this diagram is the finest example for not homomorphic image. The the homomorphic image of this diagram representing that only M4. M4 is not zero supermodular lattice. Okay, from this one I realized, because I am continuing my research, because I am standing on the platform of supermodular, zero supermodular, semi-zero supermodular, supermodular, zero supermodular, semi-lattice. I am trying to solve many problems in that. I realized many things through my guide. My research advisor feed me many things about the researches, and that I continue with a very simple thing. And final outset is that it's showing that the class of zero supermodular algebra is not equational. I told you what is it once again? Homomorphic, sublattice, I think direct product. Is it? If it is satisfied three conditions, it is the equational class. But I am trying to prove only the monomorphic image, so not equational. But what I showed here, it is show that the class of zero supermodular algebra is almost equational, because of instead of homomorphic, I try to solve the problem. What is it? Monomorphic image. Apart from that, I'm trying to solve many problems, because you know one thing, when you are starting the research means because all the statements are new. There is no exist statements. Yeah, all the statements are true, because my research thesis is I think the first evaluator is I think rejected the reject for the evaluation. The reason for only, there is no literature review for zero supermodular lattice. There is no literature review for zero supermodular lattice, because I introduced the concept, so that without literature review they couldn't able to evaluate my thesis. But the second accepted and evaluated my thesis and each and every line. Because of the main reason, all the statement is new. Entire statement is new. So only I am representing here some statements here by using pictorial proof and as well as theoretical proof. Okay, I am representing some statements only. The lattices M4 and M33 are not zero supermodular. I am representing the two diagrams. One is M4 and another one is M33. Okay, and another proof I given here, if L is a zero supermodular lattice, then no monomorphic image of L is isomorphic to M4 and M33, because it is not a zero supermodular lattice. So there is no monomorphic image is isomorphic to M4 and M33, because these statements only I from the proof I revealed these things. Okay, and apart from that, there is some proof I showed that, because the 36th PPT is it? It has more than 85 PPT, because if I want to explain each and everything in clear manner means it takes more than 4 or 5 hours. Okay, but what I want to convey you, what I want to convey you is that as a very simple thing, because I have proved, because the researchers should know one thing: you must contribute to mathematics. So what you make it anything, because in previous days the researchers mathematicians are also creating a things, because a simple idea, okay, is it possible, okay, no problem. If these type of things only making a good researchers. Okay, likewise this the statements I have proved many things. In modular lattice L, A, B, C, D are 4 elements such that any 3 elements are mutually disjoint, that is distinct, and the fourth element is comparable with at least any one. Comparable means that particular element link with the another element by the line. Okay. By the diagram, it's quite possible to understand the concept. One of the disjoint elements, then the set 4 of elements satisfying the zero supermodular law. You know one thing, the statement as written by me, so only I am telling here. Likewise, I have proved many things. A lattice Cn is zero supermodular lattice if and only if n less than or is equal to 4. There are a lot of things I have proved. Okay. I think that it is first and prime thing about to zero supermodular lattice because make definition. Yes, I written. Apart from that, I am trying to prove many theorems. I am trying to prove many theorems. Through that only, I can realize that it is a branch of lattice theory. And final outset, I want to convey with you my foreign evaluator, Dr. Antracha ma'am, as they given a merits and demerits of the theorems. And merit, they representing that as a very simple word, contemporary algebraic topic. Contemporary algebraic topic. This is what my foreign evaluator representing for my zero supermodular lattice. The reason only I told the very beginning of this session recent trends in the topic. No, zero supermodular is the recent one. But my scholars as doing research on the topic of zero supermodular lattice because I initiated everything. My research scholars are doing the same work on this topic. Okay, it's the time to end. I think time is 5 o'clock. 1 minute, please. We'll try to. Well, there are a lot of things is available in my thesis because it is the 80. I think. Well, 1 minute. I think a lot of things is there. I have prepared this material for 4 hours, but it's a very short time for me. If you give a time, I will explain each and every point. Why we take lattice, what is made, what is joint, what is supremum, what is infimum, what is poset, what are the lattices available, what is the link between the two lattices. These are all the things in my mind. I'm representing everything in this slides. I think the time is 5 o'clock. I think so. Well, if you any need also a question about the topic, please let me know, ma'am. Please. Ma'am, can you hear my voice?
Yes, sir. Can
Yeah,
able to hear your voice, sir? Yeah.
Yes, yes. Okay, thank you. If anyone means just make a question, I'll try to answer it. Well, it's possible, I think. If anyone asks about the question or apart from the topic, I try to answer it. No problem for me. Because lattice theory is a branch of universal algebra. Lattice theory is a branch of universal algebra. It's like a ring theory, field, as Madam as Esther Ma'am is a specialist in graph theory, domination graphs. You know one thing, once you select the topic, because my research advisor insists me to read the books more than 3 years. Because Arivukkarasu, if you know the whole fundamental, you can do the research within 6 months. Because without fundamental, without existence, the research is not possible. That's what my research advisor insists me always to read the books. I really thank to my research advisor only, because without him it is not possible. It's the right time to thank my research advisor, Dr. A. Vedamanikam, retired associate professor, Rani Anna Government College, Pudukkottai, sorry, Tirruchencode. Thank you very much for this time. I think if anyone may ask questions, I'll try to.
Participants Participants, if you want to ask question to the resource person, you can ask it now. Okay.
No problem. Yeah.
Okay,
Because it's
sir.
a
Thank
purely
you,
new
sir.
topic, madam.
Yeah,
The
they
people
will
cannot
take
able
some
to
time,
understand.
it seems.
I understand
Yes.
the situation because no
Thank you,
problem.
sir.
No
Thank you,
problem.
sir.
Thank you very much.
Thank you so much. Yasmin?
Yes, ma'am.
Yasmin?
Yes,
Yeah, you
ma'am.
can proceed, Yasmin. You can proceed.
Thank you, sir. So now the next few minutes will be for this section.
I mean, it's a really crucial topic, madam. Zero supermodel lattice. Because
Yes, sir.
the lattice is quite possible. You know, I think you are such, you know very well about it. And it's purely new topic. If they can understand the concept means the people may raise the questions. Otherwise, the lattice theory people in the list means it's quite possible to ask questions. Not a zero supermodel lattice. They may ask other lattices. It's quite possible. It's a really good time for me.
Okay.
Because
Oh,
many
thank you.
I am representing the zero supermodular lattice to many conferences and seminars like
Okay,
this
sir.
workshop and webinar, a lot of things. Why I am representing
Okay.
this means the further researchers may take the part means it's quite possible to do the research it's better way. That's what I'm selecting. I think you do not mistaken. I propagate the topic, I think so.
Sir, I have one question. Like,
Ma'am, please.
can you state any one or two applications based like this? What is the applications
Yes,
of this
madam.
zero supermodel?
I'm not about the supermodel lattice application, but what is the lattice theory application? It's quite possible. But it's a very simple
Okay,
thing.
okay,
You know, one thing, uh,
okay,
everyone's know as the easiest way because the Eiffel Tower, the building of the construction of Eiffel Tower, it's a purely lattice structure. Because if the lattice structure is as correct, if we are making a lattice structure means it's a very big stability, the long stability. It is the first one because in physics people are using the crystal growth. If the crystal, the lattice bond, it's in the correct way or by forming in the correct form, it's a very strong one. It makes a good stability. That is the first thing, the application of a lattice theory. But in my as a universal algebra, I'm trying to solve the problems by the algebraic structure. But I'm not going to deep in the application part. But I know the application, what is the things. But the thing is very important. But I am trying to solve the entire problem by theoretical way because I want to make a new branch in mathematics. That's what I'm trying. But
okay,
my research advisor insists me, Arivukkarasu zero supermodular lattice is purely as interrelated with the Boolean algebra. The Boolean algebra is purely interrelated with what is it? Circuit theory. So it is possible. It's really possible for circuit theory. So that you can solve the problems in circuit theory. Because then only the next level of researchers can do the research in application from the zero supermodular lattice. This is what I want to explain you now. Thank you very much.
okay, sir.
Any
Thank you so
questions?
much, sir. Thank you, sir.
Thank you.
Yasmin,
Thank you.
you can
Yes,
proceed
ma'am.
further, Yasmin. Yeah, you can proceed further.
Thank you, sir. Now I would like to invite Ms. S. Sita ma'am to deliver the thanks.
Good evening to one and all present here. I deem it a great honor and privilege to propose the vote of thanks on this 3 days national level workshop on recent trends in fuzzy inventory model, zero supermodular lattice and differential calculus and its applications. I would like to thank our honorable and respected chief guest, Dr. J. Arivukkarasu, sir, Associate Professor, Head Department of Science and Humanities, Vivekanandha College of Technology for Women, Tirruchencode, Namakkal, to grace this section. Today, we had an opportunity to hear and clarify the doubts on zero supermodular lattice. Thank you, sir. My heartfelt thanks to our managing directors and trustees, Sri KBK Rajmohan sir, Sri KB Arun sir, and Sri KB Krishnanand sir of Krishnaswamy Educational Trust. I would like to extend my sincere thanks to our beloved Dean, Dr. R. Revati, and respected Principal, Dr. Anita Rajendran, for their support to this workshop. I extend my thanks to Dr. R. Esther Felicia, Head Department of Mathematics, Shri Krishnaswamy College for Women. My sincere thanks to all the students, research scholars, and faculty members for their participation in this workshop. Last but not least, I thank our department faculty members and students for their cooperation in making this section a resounding success. Once again, I thank you all for your presence and cooperation for making this section a grand success. Thank you.
Thank you very much. Well, thank you very much, madam, for this opportunity to share my idea with you all. Thank you very much.
Thank you, sir. Sir, thank you, sir.
Thank you
And
very much.
personally, I'd like to thank you for this introducing a new topic to us, sir. It was really useful. So we'll proceed. We'll do some more papers on this topic, sir. Thank you so much.
Sure. Thank you very much. Thank
Yeah.
you. Bye.
Yes, sir. I request the feedback link to be posted in the chat box. I request all the participants to put your comments and the feedback in the feedback link for the today's session. And the feedback link will also be posted in the WhatsApp group. You can also give your feedbacks through the WhatsApp. So I thank you all for this participation and making this program a success. Okay. Thank you.